Okay, this is a great unit. Exponential growth. This is how things grow in biology. This is how things grow in economics. They also can shrink. We can have exponential decay. That's how it works in chemistry. There's a lot of good science and industry that relies on this type of math. So I'm obviously excited to teach it to you guys. Let's start with the most important thing, which is the basic equation. In this, you're going to have b times r to the x, where b is your y-intercept, okay? It's where you begin at stage 0, not at stage 1, at stage 0. And r is your rate of change. But your rate of change in exponential growth, oh, look at that, a little dyslexia came out of me, is multiplying. You're multiplying by the same thing each time. So number 1, it's y times 0.3 to the x. When we multiply by something that's less than 1, but still positive, it's going to make it get smaller. So let's take a look at Desmos. Type in y equals, I'll put my 1 in there, but I don't need it, times 0.3, and then caret x. And look what's happening. Here's our y-intercept at 1. And this is going to be what's called an asymptote. So I'm looking forward to explain more about that in person, or you guys can watch the longer video. But look, we're actually never going to get 0. Okay, if I put in a table here, if I put in 1,000, it says 0, but it's actually not true. Let's see, how could I explain that? It's rounding it to 0. What is it really? It's 1 times 0.3 to the 1,000th power. And while that estimates to be 0, it's not exactly 0. It's 1 times something that is not 0. So it can't give you 0. And here's where, if you just use the technology, you're going to end up getting confused. But like if I put in, let's see, what happens if I put in a 10? So you notice that is not 0, it's just really small. What happens if I put in 100? That is not 0, that's just really small. They just don't feel like giving me the scientific notation version of this one, so they're like, screw it, I'm done. I'm just going to tell you it's 0. But trust me, it's not. Well, that took a little longer than I thought. So let's see. Let's do y equals 1/2 times 3 to the x. Let's look at what that looks like. Okay. .5 times 3 to the x power. See, this is what you want your money to do. Notice my y-intercept is 0.5. That's exactly what we thought. But every time I go over 1, we multiply by 3. Over 1 up 3. Over 1 up 9. Over 1 up 27. This thing gets out of control super fast. Now, don't let it mislead you again. This is our asymptote. Oh, come on, get down there. So if you click on the point, it's close to 0, but it's actually just approaching 0. And I'll have to explain that to you guys when you have a little bit more time to look at it deeply. Also, if I put in a 10, it's not like it doesn't exist. If I go to my table again, if I change this to 10, we have an answer. It's just huge. 29,524.5. Okay, if I put in a 20, look how much bigger it gets. Now we're talking about on the level of trillions. Okay, but notice if I put in a negative 10, I get an answer. It's just super small, super small. Notice that we said that science uses this a lot, and now we're going to start using scientific notation a little because our answers are just too big to handle. Okay, so look, it's multiplying by a third. That's decay. It's multiplying by more than 1. That's growth. Decay, growth, growth, growth. Find the y-intercept. 20, 2/3, 1/5. You guys are all over this. Find me with questions. Be curious.